Welcome to Distort, the show where we distort time in order to show you things you might otherwise miss with the human eye. I'm Mauricio.
And I'm David, and today we took our experiments 4 stories up at the San Francisco Fire Department training facility on Treasure Island.
We were responsible for dropping objects. Who's responsible for dropping science this week?
That would be Joe.
Joseph.
Joseph?
Dr. Joe?
Dr. Joseph, is it Joe or Joseph Barranco?
Joe's fine.
Joe Barranco is our gravity expert this week.
Ever since I was young, I always wanted to be an astronaut. I used to always watch Star Trek, Star Wars, Flash Gordon. I always wanted to explore outer space. I went to college at Harvard and studied physics, astronomy, and astrophysics.
He then went on to UC Berkeley
and received a PhD in astrophysics and been doing that ever since.
That's pretty awesome. So he can explain to me, as if I were a 5-year-old, why gravity is one of the strongest forces in the universe.
Well, there are no dumb questions in science, except that one.
It's actually the weakest force in the universe. And the way to think about that is it takes the entire Earth to keep us held onto the Earth. Newton's third law says the egg is pulling up on the Earth with the exact same force that the Earth is pulling the egg down.
So this egg right here is pulling the Earth towards it.
Yep.
Wow. Take that, Earth.
Even though the force is the same, to get the acceleration, you have to take that force and divide it by the mass.
Oh, okay, so the speed at which the Earth is accelerating towards the egg is
pretty much non-existent.
In everyday life, if I drop a book and a piece of paper, they don't hit the ground at the same time. But if we were to take out the air from the entire Earth, get rid of our atmosphere.
So we're in a vacuum.
So we're in a vacuum, all right? We'd be dead. Fortunately for us, there is an atmosphere, because that's what we need for life. But if you could imagine a situation where you got rid of the entire atmosphere and dropped a book and a piece of paper, they would hit the ground at exactly the same speed and time.
Well, in my left hand, I have a feather. In my right hand, a hammer.
If we were on the surface of the moon that has no atmosphere, I could take a feather and take an anvil and let go, and they're going to hit the ground at the same time.
One of the first astronauts actually did that experiment.
Oh, really?
When he landed on the moon.
And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time. How about that?
But we're not on the moon. We're here on Earth, where there's air.
What he said.
The basic idea is, as an object is falling through the air, there's all this air molecules in front of it that it has to push out of the way. Terminal velocity is at a point where the amount of drag force pushing you up is equal to the weight of gravity pushing you downward.
You spell terminal? No, I'm kidding.
When you have a situation where forces are in balance, the rest of the way the object will just coast at a constant speed. It won't speed up, it won't slow down, it'll coast the rest of the way down.
Awesome. So how many times did we hit terminal velocity from 4 stories?
Well, I did a few of these calculations just to verify. With my estimate, I expected the terminal velocity for an ostrich egg to be 130 miles per hour. But in 4 stories, you don't get anything close to that, and you get to 60 miles per hour. So the ostrich egg definitely not going at terminal velocity.
Oh my God.
Damn it.
What about the champagne bottle?
For that object, I treated it as a cylinder,
Yeah.
and I estimated that it would reach a terminal velocity of 80 miles per hour. So again, we didn't quite get there because by the time you hit the ground, you're going at about 60 miles per hour, not quite all the way there to terminal velocity.
Gotcha.
The printer?
Estimated that too. I treated it as idealized it as a pure cube.
Yep.
And estimated that. And for that, interestingly enough, I got 130 miles per hour.
Whoa. What else did we have?
Unfortunately, you dropped a keg of beer.
Oh, yes.
I estimated that to have one of the highest terminal velocities. I estimated that to be about 150 miles per hour.
Well, looks like we failed, you guys.
Yeah, the average terminal velocity of your everyday object is about 80 to 100 miles an hour, and we didn't quite get there. How many stories up would we have needed to be to get that 130, 140 miles an hour?
Yeah, exactly in that range of 80 to 100.
Yeah.
Again, depending on the shape. You would have to get up to over 10 stories.
But wait!
A pineapple.
Oh, yes.
I estimated would have one of the smallest terminal velocities, and I was basing it off the fact that it's a very rough surface, has a smaller terminal velocity. So I estimated that to maybe be about 55 miles per hour.
And so we might have gotten close.
Maybe with the pineapple you actually hit terminal velocity.
Yeah.
Sir, good job.
We did a science.
Damn right.
Huge thanks to Dr. Joe Barranco from San Francisco State University for teaching us a lesson in physics.
And thanks to the San Francisco Fire Department for letting us use their facilities. Also, if you want to check out all of these slow motion clips in their entirety, go to testtube.com/distort. You'll see new clips there every Tuesday.
And huge thanks to a brand new show that hasn't launched yet called Brew Age for giving us a keg to drop and waste.
What a waste.
They're launching a brand new show. Check out the trailers for all things beer. Can't wait for it to launch. Brew Age, awesome show. Check out the trailer.
All right, subscribe, comment below, and we'll see you next week.
Are there people in your field that, I didn't even think about this question, that would think about the quote unquote splat radius based on how fast it's hitting the ground?
You know what, I don't think physicists would do that, but I'm sure a lot of forensic scientists need to know that.
Splat radius.
The splat radius of something falling.
I kind of missed you altogether.
What's that?
I kind of missed you.